Hi everybody, so today we're going to be looking at the chemistry that we can find in a Simpsons episode. We're going to be looking at the second episode of the first season. In this episode, Bart is accepted to a school with a gifted program after he cheats on the admissions intelligence test. While he's in the lab, he mixes two chemicals, and his teacher asks him if he knows what occurs when acids and bases are mixed. Reaction occurs as soon as he mixes the chemicals in his hand, and I think it's safe to assume that he mixed an acid and a base.
I'm still trying to get you a lab partner, Bart. If we don't get any volunteers soon, I'll assign somebody. Say, what's that? It looks dangerous.
Well, it's really pretty top secret, ma'am.
All right, keep going. But you do know what happens when you mix acids and bases, right?
Of course I do. Sorry.
So that's a pretty exaggerated representation of acid-base reaction. But before we go into that, let's define acids and bases. Acids are molecules that are capable of donating a proton, H plus ions. They have pH levels under 7. 7 strong acids are hydrochloric acid, hydroiodic acid, hydrobromic acid, perchloric acid, chloric acid, nitric acid, and sulfuric acid. Bases are molecules that accept those hydrogen ions from the acids, and they release hydroxide ions, otherwise known as OH-. They have pH levels above 7, and strong bases include lithium hydroxide, potassium hydroxide, sodium hydroxide, rubidium hydroxide, cesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. So what happens when an acid and a base reacts? When they react, that's called a neutralization reaction. In a neutralization reaction, acids and bases react to form water, H2O, and a salt. The salt is between the anion in the base and the cation in the base and the anion in the acid. So a strong base and a strong acid will cancel each other out evenly, and they'll have a pH level at 7, a neutral pH. But a strong base and a weak acid will have a pH level above 7, so that will be it will produce a basic solution due to the strong base overpowering the weak acid where there's an excess of hydroxide ions. And a weak base and a strong acid will have a pH level under 7 due to the fact that the acid is overpowering the weak base due to the excess in hydrogen ions. An example of a neutralization reaction is on the bottom with a sodium hydroxide molecule and a hydrochloric acid molecule. So these react to form H2O and sodium chloride, what we know as salt. This salt will stay after you evaporate the water molecules. And on the side, we have a real representation of Bart's reaction between a acid and a base. So as the reaction occurs, we definitely see the same fizzing that initially happened in Bart's reaction, but we can see that it's way more simpler than Bart's reaction. Bart's exploded on everybody, and it distributed all throughout the lab, and it caused problems for him. But that really wouldn't occur with a real acid and base reaction, especially when you only have that small amount in two test tubes. So that's an exaggeration, but so now we know what happens with the real neutralization reaction. thank you guys for watching, and that's my chemistry film festival.